Good morning, Middle 2. Our lesson for today is force. First, to understand the concept of force, we must study some situations like when I have a book on a table, it will remain static as no effect or force acted on it. When I have a static ball and a player kicked it, it will change its state from static to motion. Why? Because there is a force acted on it. If I try to push the wall won't move because the force or the effect that acted on the wall is not proper. So, the force is an effect that attempts to change the object face from being static to motion, and vice versa, or attempt to change the direction of motion. So, if I have a moving ball and the player kicked it in the same direction of its motion, its speed will increase, while when the force was in opposite direction, the ball will change its direction. The measuring unit of force is Newton. Okay? So, the force is an effect that attempts to change the object face from being static to motion, or vice versa, or attempt to change the direction of motion. There is many types of force that found in nature, and we can divide it into two main types. First, forces that found in natural phenomena and forces that causing technological applications. First, the forces that found in natural phenomena. I have the forces that found in lightning and thunder, or wind motion, or the gravitational of Earth, and the attraction of iron to magnet. Then I have forces that causing technological applications like generating electricity or fire weapons or nuclear explosions and nuclear reactors. There is another classification of forces that is fundamental forces in nature. We have first the gravitational forces that is related to the Earth to attract any object on it. Then electromagnetic forces and nuclear forces, which is divided into weak and strong. First, the gravitational of Earth or the Earth's gravity. When I have certain objects with different masses and I wanted to lift them on a table, if the first object, the mass is 1 kilogram and the other is 5 and 10 kilogram, I will start to lift the first object by a certain power. Then I must to increase the exerted work to lift the second one because its mass is larger than the first one. And then I need more work or more force to lift the heaviest one, which is 10 kilogram. So I have to increase my work or the force to lift the object as the mass increase. Earth attracts the object to its center by a force called object weight. So the attraction forces of Earth, I can say it is object weight. Object weight increases by increasing the object mass and vice versa. So the definition of object weight will be it is the ability of Earth to attract the object to its center, or it's the force of Earth's gravity, the force of Earth's gravity on the object. Then I have object center of gravity. It is the effective point located at the center of the object at which the force of gravity affects the object. I have a relation that I can calculate the object weight. Object weight will equal the object mass times Earth's gravity acceleration, which is a known quantity, 9.8, or I can make it 10 meter per second square. Very important note, the object weight is changeable while the mass remain constant. Why? The object mass is related to the amount of matter that the object contains, while the weight is equal the mass times gravity acceleration, Earth's gravity acceleration. So the object weight can be changeable, but the mass remain constant. Let's start with an example. Find the weight of an object of 100 kilogram mass, knowing that the Earth's gravity acceleration equal 9.8 meter per second square. So from the previous relation, object weight equal object mass times Earth's gravity acceleration. So the object weight will equal 100 kilogram times 9.8 equal 918 Newton. Another example, find the mass of an object of 218 Newton weight. So I have the weight, knowing that the Earth's gravity acceleration equal 10 meter per second square. Object weight equal mass times Earth's gravity acceleration. So the mass equal object weight over Earth's gravity acceleration. So the mass will equal 280 over 10 equal 28 kilogram. So there is an important note about object weight, which is the object weight related to the Earth's gravity acceleration and the mass. And we said that the mass is fixed value, whereas the object weight changes from place to another on the Earth's surface due to the change of Earth's gravity acceleration. As gravity acceleration changes from one place to another on the Earth's surface due to the non-spherical shape of Earth. Okay, as the Earth non-spherical, so the two poles length or height is different from the equator, and I have a very strong relation between the object weight and the height. So as the object weight decreases when the height increases, and vice versa. So the object weight increases as the height of the object from the center of the Earth decreases. So the gravity decreases when the height increases and increases by approaching to the Earth's center. So the gravity is less stronger at equator than the two poles. Thank you.